Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class, we are going to continue the first chapter in chemistry, that is chemical reactions and equations. And remember, this is sixth period of this chapter. In fifth period, we were getting the detailed information about each type of chemical reactions. Is it not? First one, that is chemical combination or combination reaction, was discussed completely through some of the experiments as well. And the second one, decomposition, we were about to finish this one. Now let's go for continuing this. You all know that decomposition reaction is carried out in the presence of different forms of energy. What are these? Even it can also be asked like this: what are the different forms of energy which are responsible for decomposition reaction? What do you say? One is, it is heat energy. Second one is light energy. And third one is, electrical energy. Is it not? Then heat energy, it is nothing but thermal energy. Next, light energy, it is the energy obtained from the sun, nothing but solar energy. Electrical energy is nothing but electricity, right? And from these also we can go for understanding the different types of decomposition reactions. Here I'll write types of decomposition reaction. Types of decomposition reactions, and these types are based on the different form of energy that we use for carrying out. Here, first I will take the example so that you will be able to tell yourself. We are very familiar with one chemical reaction, that is FeSO4. When FeSO4 crystals are heated, what happens? It decomposes into Fe2O3, which is ferric oxide, then SO2 plus SO3, right? That is sulfur dioxide and sulfur trioxide. Next one, I'll take one more. It is PbNO3 twice lead nitrate crystals. They are white in color. Then when it is heated, then it gets decomposed into PbO, lead oxide, which is yellow in color. Next, the brown fumes will be coming out, that is nitrogen dioxide, and the burning incense stick, when it is introduced into the test tube, then it burns brightly. That indicates oxygen gas is released. See, these are the chemical reactions, nothing but decomposition reactions, which are carried out by supplying heat. What do you call that? It is called thermal decomposition. Once I repeat, the decomposition reaction which is carried out by supplying heat is called thermal decomposition. I'll take some more example. Third one is, it is very important, KClO3. Name this compound. It is potassium chloride. When it is heated, then it gets split up into or decomposes into potassium chloride plus oxygen. And please do remember, this reaction is used for preparing oxygen in the laboratory. Clear? Here, for your reference, I'll write oxygen in laboratory. They may ask you, write the decomposition reaction used for preparing oxygen in the laboratory. You will have to write this one. Next, I'll write one more. It is calcium carbonate. What is the common name of calcium carbonate? It is limestone. Then also called marble. When it is heated, then it produces the compound called calcium oxide. Then carbon dioxide gas is released. Remember this also. and this chemical reaction is used in the preparation of cement, in the manufacture of cement. Remember that. Okay. Yes. These are the chemical reactions or decomposition reactions carried out by supplying heat, and hence these are called thermal decomposition reaction. Understood? Yes. I'll go for second one. And before going to name that, I'll just give some of the examples. Alright. AgCl. Name this compound. It is silver chloride. What happens when it is exposed to the sunlight? That is, then it absorbs the energy coming from the sun and decomposes into silver and chlorine. Clear? Next, another one, AgBr. That is silver bromide. Again, when it is kept in the presence of sunlight, then it gets split up into silver and bromide. Please do remember. See, these are the chemical reactions, nothing but decomposition reactions, which are carried out in the presence of sunlight, and such chemical reactions are called photolysis. Photolysis, also called photochemical reaction. Photo, P-H-O-T-O, nothing but light. Photochemical reaction. Understood? And remember, these reactions are used in black and white photography. In black and white photography. Just remember this. Next. I'll go for taking next one. Third one. Before that, once I tell the definition of photolysis. What is photolysis? The decomposition reaction which is carried out in the presence of sunlight is called photolysis, also called photochemical reaction. Now, third one. Here I will take some of the examples which are very familiar to us. It is, name this compound. It is water, acidified water. Then what happens when electricity is supplied through it? It gets decomposed into hydrogen and oxygen. Clear? Yes. I'll go for one more. Sodium chloride. It is a common salt. Then when the electricity is supplied through aqueous solution of sodium chloride, then it gets split up into sodium and chlorine. Clear? Yes. And these are the decomposition reactions which are carried out by passing electricity, and such reactions are known as it is electrolysis. Electrolysis. Already we have got information about this through an experiment as well. So these are the three different types of decomposition reactions. One is thermal decomposition, second one is photolysis, third one is electrolysis. So now I will go for writing the definitions of all the three. Yes, I have written the definition. Please go for copying as it is. First side heading is the different forms of energy by which decomposition reaction takes place. These are the three ways. Next, after that, types of decomposition reactions. Thermal, definition, example. Next, photolysis, definition, examples. Third one, electrolysis, definition, and I have given two examples. Please copy from there to here. Okay, dear students, again I am going to take some of the examples for decomposition reaction. You just keep observing. Here, KClO3. Yes, what happens when it is heated? It produces KCl plus O2, potassium chloride and oxygen. Please do remember, here to produce these two products, obviously it should be heated. By heating, potassium chloride will absorb the energy. What do you call that energy? It is heat energy. Here I'll write plus heat energy. Clear? Similarly, I'll go for taking AgCl. AgCl, when it is exposed to the sunlight, then it absorbs the heat energy from the sun and decomposes into silver and chlorine. Right? Similarly, PbNO3 twice, that is lead nitrate, and when it is heated, it absorbs heat energy then to produce the compounds like lead oxide plus nitrogen dioxide plus oxygen. Look here, in all these chemical reactions, heat is absorbed and we call that chemical reaction as endothermic reaction. Endothermic chemical reaction. Endothermic reaction. Endo means what? Within, inside. Thermic, heat. That is, heat is absorbed. The chemical reaction which takes place by absorbing the heat is called endothermic reaction. And these are the examples for endothermic reaction. Clear? Dear students, we are going to use decomposition reactions for different purposes. I have already told you some of them. Decomposition reaction is used in the manufacture of cement, right? Even glass also. Manufacture of cement and glass. So for this purpose, we go for using a compound called limestone, that is calcium carbonate. It undergoes decomposition reaction to produce calcium oxide and carbon dioxide. Similarly, the compounds like AgCl, nothing but silver chloride, and AgBr, silver bromide, and these are used in black and white photography, right? So decomposition reaction is used in black and white photography. Black and white photography. That is, just I'll give you an example. AgCl. Not only this, even the decomposition reaction is used in the preparation of oxygen in the laboratory. I have already given you one example. That is, when potassium chloride is heated, it produces potassium chloride and oxygen. See that oxygen is obtained. So it is used in the preparation of what? Oxygen. Oxygen in the laboratory. In the laboratory. Then here in bracket I'll write which one? KClO3. Just one more example. Next, one more important. I'll write Al2O3. Al2O3. What happens when Al2O3, through that electricity is passed, Al2O3, it gets decomposes into aluminum and oxygen. See that to extract the metal from its ore, aluminum oxide is a ore of aluminum. To extract the metal from its ore, we will go for using decomposition reaction. So here are we. In the extraction of metals from their ore. Clear? Just one example, Al2O3. So these are the uses. So now we'll move on to the next part of this chapter. Before that, I'll write the definition of this endothermic reaction. Observe, here I have written the definition for endothermic reaction. The chemical reaction in which heat is absorbed to form the products is called endothermic reaction, and these are the three examples for endothermic reaction. Next, so this is next heading is uses of thermal decomposition. Below that you can write thermal decomposition reaction is used, or else it is used one by one in the manufacture of cement and glass, in black and white photography, then in the preparation of oxygen in the laboratory, and in the extraction of metals from their ore. Clear? Yes. Please go for copying from there to here. Dear students, now we are moving to the third type of chemical reaction. What is that? It is displacement reaction, right? And we know that its definition. The chemical reaction in which an element in the compound is displaced by another element which is more reactive, right? Here the more reactive element will change the position or will displace the position of the less reactive element present in the compound. That's the definition. So we have already got an information about it. Now here we are going to conduct an experiment related to displacement reaction. To show displacement reaction. But in the examination, how the question can be asked? It is like this. With a neat labeled diagram, show the displacement reaction with a suitable example. Here I am going to take example, that is the reaction between copper sulfate solution, CuSO4 solution, and iron, that is Fe. The materials required are, we need test tubes, 2 test tubes, and an iron nail, thread, iron strand, this much. First, you prepare copper sulfate solution and take them in the 2 test tubes and name the test tubes as A and B. This is A and this is B. You all know that the color of copper sulfate is CuSO4, right? CuSO4 solution. Here, CuSO4 solution. Then I am going to take any one of these two, either A or B. Let us take B, the test tube B, and fix the to an iron stand. Here, this is test tube B in which copper sulfate solution is present. Got it? Next, take a thread and one end of it should be tied to the stand and another end is to be tied to an iron nail. And do remember, before using the iron nail, please wipe it with the sandpaper. Then unwanted impurity, maybe if it is rust, it is get removed. Then what will be the color of the iron nail? Yes, it is silvery grey. Remember that. Silvery grey. Now, immerse that nail into the test tube and allow it for 15 to 20 minutes. Please don't go for disturbing it. Then what will be your observation after 15 minutes? You will come to know that, see, here you can notice that the color of the solution changes from sky blue to, it is pale green. Got it? Observe. It turns to pale green, and that pale green indicates it is the color of iron sulfate. Then you will remove the iron nail. On removing iron nail, you can come to know that there will be brown coating or brown patches on it that indicates it is copper. Cu. Got it? And here this green color solution is known as iron sulfate, FeSO4. Did you understand? So here we can write the reaction like this. Iron reacts with copper sulfate solution CuSO4 and forms iron sulfate FeSO4, then copper gets separated. Here we all know that iron is more reactive than copper and displaces copper from its solution, copper sulfate solution, to form iron sulfate and copper. Got it? So here, as the element present in the compound is displaced by another element which is more reactive, hence we can call it as displacement reaction. Did you understand? The procedure is very simple. Now I am going to write it. Before that, once I tell you, take two test tubes and prepare copper sulfate solution, then and fix the test tube B to the iron stand. Next, take a iron nail and tie it with a thread. Then immerse that into the test tube and leave it for about 15 to 20 minutes. Then observe the solution present in the test tube. Then on compare, here for comparison only we have taken copper sulfate solution in A. So on comparing we will come to know that it is observed that the solution turned to pale green, which indicates it is iron sulfate solution. Clear? Then remove the iron nail. We can come to know that the iron nail is coated with brown, which indicates copper is deposited on it. Then the reaction can be written like this. Fe plus CuSO4 gives rise to FeSO4 plus Cu. So here copper is displaced by iron, which is more reactive, to form FeSO4 and Cu. Therefore it is displacement reaction. Did you understand? Yes. Now I'll write the procedure. Just go for drawing the figure. Dear students, hope that you have written this and you might have drawn. Here I have labeled, see, iron stand, test tube, then copper sulfate solution which has been prepared using water, therefore it is called aqueous solution. Then iron nail, then thread has been used. Then after that we will go for using two nails. One nail will keep that as it is and another nail which is to be immersed in the copper sulfate solution, because at last just we can compare what changes that is observed in the nail. Next, here two test tubes. In first one copper sulfate solution, second one there also we had taken copper sulfate solution, but after the chemical reaction it has turned to pale green color FeSO4. Okay, after writing up to here, then procedure. Just go through this. Take two iron nails and clean them by rubbing with sandpaper. Next, take about 10 ml of copper sulfate solution in each test tube and name them as A and B. Fix a test tube B to the iron stand and immerse an iron nail into it and keep one nail aside for comparison after the chemical reaction. Next, after 20 to 30 minutes, take out the iron nail from copper sulfate solution. Then we can observe that solution in the test tube B turns pale green, which is FeSO4, and brown coating on the nail is copper. That chemical equation can be written as Fe plus CuSO4 gives rise to FeSO4 plus Cu. Here iron displaces copper from copper sulfate solution to form iron sulfate and copper. Therefore it is a displacement reaction. So please go for writing neatly from there to here. Okay, dear students, now we are moving to another experiment, but this is related to fourth type of chemical reaction, that is displacement, double displacement reaction. See, to show the double displacement reaction, they may ask you in the examination that explain double displacement reaction with a neat leveled diagram taking suitable example. So here For this reaction, I am going to take, it is barium sulfate sodium sulfate and barium chloride. Observe, sodium sulfate solution, reaction between sodium sulfate and barium chloride. Very simple experiment it is. Here we have to take two test tube. In one test tube, you prepare the aqueous solution of sodium sulfate, Na2SO4 solution. Take the crystals of sodium sulfate in the one test tube, then add water to it. Then go for shaking it well. Then we get sodium sulfate solution. It is colorless. Do remember. Next, similarly, in another test tube, take barium chloride crystals, add water to it, distilled water, and shake it well. Then it becomes barium chloride solution, BaCl2 solution. It is also colorless. Then go for mixing one into the other. You may mix sodium sulfate solution into barium chloride solution, or barium chloride solution into sodium sulfate solution. Then, do you know what happens? You will notice that a white color precipitate is formed along with a solution. See, this is the solution. In that, a white color solid substance is formed, and this precipitate, that solid substance is known as precipitate. Clear? Then which is that precipitate? It is sodium. It is barium sulfate, BaSO4, barium sulfate precipitate, and the solution is sodium chloride. Followed? Then you all may be thinking that what is that precipitate? We have already got the information. Precipitate, it is a solid chemical substance which is formed during the chemical reaction and is insoluble in the solution. That is called precipitate. Even you can recall one more example what we have taken in the very beginning. Lead nitrate reacts with potassium iodide solution, then to form a yellow color precipitate called lead iodide, right? Yeah. Now, let us come to this. Just it is observed that a white precipitate of barium sulfate is formed along with sodium chloride solution, and the chemical reaction can be written like this. It is Na2SO4 plus BaCl2 gives rise to, it is BaSO4 plus NaCl. Observe, the ions that are present in Na2SO4 is Na plus SO4 2 minus, sodium ion and sulfate ion. In barium chloride, Ba2 plus Cl 1 minus, barium ion and chloride ion. So these ions, the ions present in the reactant side, exchange mutually to form two new compounds, BaSO4 and NaCl. That is why it is called double displacement reaction. Clear? So I'll go for writing the procedure. Before that, once you listen to me carefully, very simple. Take a test tube, then prepare sodium sulfate, about 10 to 20 ml of sodium sulfate solution. Then prepare barium chloride solution and take that in the another test tube. Go for mixing them, or mix sodium sulfate solution into barium chloride solution, right? Then it is observed that a white precipitate of barium sulfate is formed along with sodium chloride solution. Clear? And this is the chemical equation. Yes, please go for copying the question then and this example, Then you go for drawing up to here. I'll go for writing procedure. Observe, here I have written the procedure. See, very simple. First, take about 10 ml of sodium sulfate solution in one of the test tube. Then in another test tube, take about again 10 ml of barium chloride solution. Then mix the two solutions. I have told you, either you may mix sodium sulfate into barium chloride solution or barium chloride solution into sodium sulfate solution. Next, then we will observe that a white precipitate is formed. Which is that white precipitate? It is barium sulfate. Along with the solution remained is, it is sodium chloride. That chemical equation can be written like this. Na2SO4 BaCl2 gives rise to BaSO4 plus NaCl. Dear students, I have been telling you repeatedly that whenever you may go for writing any chemical equation, it must be balanced. You may give the example for some of the definition, or you may get the chemical equation with respect to the experiment, whatever it is. Whenever you write the chemical equation, let it be as balanced one. Next, here you can come to know that the ions present in the reactants exchange mutually to form two new compounds. Therefore, it is a double displacement reaction. Yes, please go for copying the procedure from there to here. Dear students, with respect to double displacement reaction, there was a question which was given in the examination. I have written the same. Observe it. Consider the reaction between lead nitrate solution and potassium iodide solution. And you have to answer for these questions. First question, write the color of the solutions. We know that color of crystals of both, color of crystals of lead nitrate is white. Then potassium iodide, that is also white. But in their solution form, both are colorless. Okay. So the color of the solutions, it is colorless. Next, here only I will go for writing the answer. For first one, it is color is colorless. Then second one, name the products that are formed by the reaction between these two, lead nitrate and potassium iodide. We will get lead iodide and potassium potassium nitrate. Here I'll write. One is lead iodide and potassium nitrate. Next, third sub question is, what was the color of the precipitate so formed in these two? Which is the precipitate? Precipitate is lead iodide. The color of this lead iodide is yellow. The color of the precipitate is yellow. Which is that? Lead iodide, PbI2. Write its chemical formula. We have written PbI2. Next, fourth one. What type of chemical reaction is this? Could you tell? Here, two compounds mutually exchange their ions to form two new compounds. Therefore, it is called double displacement reaction. Here I'll write. It is a double displacement reaction. Double displacement reaction. And we can also extend that to one more question. Write the balanced equation. Write the balanced chemical equation with respect to this chemical equation. How do you write? See, first one is PbNO3 twice plus. Second compound is potassium iodide. Then the products so formed are PbI2 plus. Then potassium nitrate, KNO3. How do you go for that? Here, oxygen. This compound has maximum number of atoms. So oxygen has 6, but here is 3. You can go for writing it as 2. Now oxygen atoms are balanced. Next, 2 atoms of potassium. Here I'll write. Then 2 atoms of iodine. Next, nitrogen, 2 atoms. See, 2 atoms, like 1 as it is. Yes, please go for copying from there to here. Copy. Dear students, with respect to just what we discussed, I am going to take some of the examples. Please observe them. Here, which is most familiar to you, it is Na2SO4 sodium sulfate. It reacts with barium chloride solution. Then what we get? It is barium sulfate plus NaCl solution. It is solid and this is aqueous, and these two are also aqueous. Similarly, lead nitrate solution PbNO3 twice aqueous plus potassium iodide solution. This is also aqueous because it is prepared from water. Then we will get PbI2. Is it not? It is solid plus it is KNO3 aqueous. I take one more. CaOH twice. It is aqueous plus CO2. It is gas. Gas is passed into aqueous solution of calcium hydroxide. We will get CaCO3. This is solid plus water. Observe all the three chemical reactions. And what do you say about the product? Look here, two aqueous solutions together form a solid. Two aqueous solutions react with each other to form a solid chemical substance, but it is insoluble in the solution. And here a gas is passed into the aqueous solution. Again we have got a solid chemical substance which is insoluble in the water. Then what do you call these solids? These are precipitate, right? And in all these reactions, precipitate is formed. Hence, these reactions are called precipitate reaction. Got it? Then how do you define precipitate reaction? Precipitate reaction can be defined in this way. The chemical reaction in which a solid chemical substance is formed and which is insoluble in the solution. Got it? It is called precipitate reaction. Then what is precipitate? Precipitate is a solid chemical substance which is formed as a result of chemical reaction. Got it? And this precipitate is formed under two important conditions. Please observe, I have given both of them. Here, aqueous solution, aqueous solution. When two aqueous solutions react with each other, then precipitate is formed. Next, another one is when gas is passed into the aqueous solution, again precipitate is formed. Once I repeat, precipitate is formed under two important conditions. One is the reaction between two aqueous solution, and second one is a gas is passed into the aqueous solution. Clear? Yes. Now I will go for writing the definition of that. Observe, here I have written the definition of precipitate reaction. A chemical reaction in which precipitate is formed, or else a chemical reaction in which a solid chemical substance, nothing but precipitate, which is insoluble in the solution, is called precipitate reaction. And these are the three, and I have written one more example. In the fourth example, I have taken copper sulfate solution. When hydrogen sulfide gas is passed into the copper sulfate solution, then we get a precipitate called CuS, copper sulfide, and hydrogen sulfate solution of sulfuric acid. Then these are the examples. Here I have written what are the conditions under which the precipitate is formed. I have already told you. First one is when the two aqueous solutions react with each other. That is, in the reactant side both should be aqueous. And second one, when gas is passed into the aqueous solution. Clear? Yes. Please go for writing from there to here. Copy that. I hope that we have written this up to here. Next, just observe examples for chemical reactions. Here one is HCl and another one is NaOH. Then what will be the products? First you name them. What is HCl? Hydrochloric acid. Sodium, it is NaOH is sodium hydroxide. And the compounds that are formed are, it is NaCl plus H2O, right? Here also hydrogen and chloride ions will mutually exchange with sodium and hydroxide ion to form two new compounds. Then what type of chemical reaction it is? It is double displacement reaction. It is also double displacement. I go for taking one more. It is HNO3. What is this? Nitric acid. Is it not? Then KOH. It is potassium hydroxide. What will get? It is KNO3, potassium nitrate plus water. Is also an example for double displacement reaction. I'll take one more. It is H2SO4. Name this compound. Sulfuric acid. Then CaOH twice. Name this. Calcium hydroxide. What will get? It is CaSO4 plus H2O. Here no equation is balanced, but you must do that one. Okay, in all these, the ions on the reactant side will mutually exchange to form two new compounds. Hence, there are examples for double displacement. But one more thing you can notice that here, what do you call these HCl, HNO3 and H2SO4? They are all acids. What do you say about NaOH, KOH and CaOH twice? They are all bases. Then acids react with bases to form. What do you say about sodium chloride, potassium nitrate and calcium sulfate? They are all salts. Is it not? And this is water. It is nothing but acid-base reaction. When acid reacts with base or base reacts with acid, they form salt and water. What do you call this reaction? Yes, very good. You are right. It is called neutralization reaction. Here are right. Neutralization reaction. Then how do you define this? Yes, when an acid reacts with base, then it forms salt and water. This is known as one is neutralization reaction or acid-base reaction. Neutralization reaction, and these are the examples. Okay, and along with that, please go for copying this also. All these will come under double displacement reaction. Copy this. Dear students, now we are moving to the fifth type of chemical reaction, that is oxidation and reduction reaction. We are going to explain the experiment with respect to this by taking suitable examples. Just once you go for recalling this, oxidation means addition of oxygen or removal of hydrogen, and reduction means addition of hydrogen to a substance or removal of oxygen from a substance in a chemical reaction. Here we are going to take the suitable example, that is copper powder. Let us come to know how we can study this oxidation and reduction using this copper powder. Here, this is the experimental arrangement. Here we have the china dish, and in that we have taken copper powder, which is brown in color. Then this is white gauze and is iron stand. Sorry, it is Bunsen burner. Then this is flame. Look here. Now let's go through the procedure. Take some amount of copper powder, maybe 5 gram or 10 gram of copper powder in a china dish and place it on the wire gauze which is placed over tripod stand, and below that we have placed the Bunsen burner. Then start providing heat. Do you find any changes in that? Yes. You can notice that this copper, the brown color copper powder will start turning into, yes, you can observe the color. What is that color? It is black. Clear? Why it happens so? Because when heat is provided to the copper powder which has been taken in china dish, it reacts with oxygen present in the atmosphere, and this copper reacts with oxygen and produces the black residue that is called CuO, copper oxide. Clear? This is copper oxide. It starts turning. Got it? Next, see that it is addition of oxygen to a substance. Then we get copper oxide. It is an example for oxidation reaction. Now, whatever the residue will remain, nothing but copper oxide. Take that into the test tube. This is CuO. Then assume that we have collected the hydrogen gas into this first test tube. It is hydrogen gas, and this hydrogen gas is passed into copper oxide. What will happen? It will start again turning into, yes, brown. That is, here we can write like this: copper oxide reacts with hydrogen. So addition of hydrogen to a substance is reduction. Then we will get copper gets separated plus H2O. So is an example for reduction, and this is oxidation. Clear? Very simple. First, copper powder is heated in the china dish. So as it on heating, it reacts with oxygen present in the atmosphere and forms a compound called copper oxide. Here oxygen is added to the substance, therefore it is oxidation. Next, whatever the residue will remain, that is copper oxide, pass hydrogen gas into the, or pass hydrogen gas over copper oxide, it start turning slowly into the brown color, which indicates it is copper. Then water vapors are formed. Here addition of hydrogen to a substance, therefore it is called reduction reaction. Clear? So now I'll go for writing the procedure. Please go for drawing this. Copy that question, then you go for drawing this figure. Here I have labeled all the parts, then you too go for doing the same. Next, after that you have to write the procedure. It is very simple. First we have taken 5 gram of copper powder in a china dish. Then it is heated over a Bunsen burner flame. Then we will observe that brown color copper turns to black, which is nothing but copper oxide is formed. It is because copper reacts with oxygen, that has been shown here. Cu plus O2 gives rise to CuO. In this chemical reaction, oxygen is added to a substance, therefore it is an oxidation reaction. Then after that, you just pass hydrogen gas over copper oxide. So this black color copper oxide turns brown, that is copper. Again, copper is formed. That reaction can be written like this: CuO plus S2 gives rise to Cu. Then the bubbles, you can see the bubbles near the mouth of the test tube, that indicates water is also formed. It is in the form of vapors. Next, in this reaction, hydrogen is added to the given substance, therefore it is a reduction reaction. Clear? Hope that you have understood. Yes, please go for copying by labeling these diagrams, then with procedure. Copy this. Dear students, now I am going to take some chemical reactions with respect to oxidation and reduction. Just observe here. Here, just we had come across one chemical reaction where the black color copper oxide reacts with hydrogen to form copper and water. Is it not? The equation is not balanced. Just observe it. It is balanced only. Observe it. Here, this is copper oxide which has oxygen in it, and this is the substance which is ready to give oxygen for oxidation. Then to which one it gives oxygen? Copper oxide can give oxygen to water, then oxygen to hydrogen, then hydrogen get oxidizes to water. That means it takes oxygen and becomes water. Next, when the copper oxide gives the oxygen, then it get reduced to copper. Right? Here, this is the substance which gives oxygen for oxidation, and this is called oxidizing agent. Oxidizing agent. Once I tell you, the substance which gives oxygen for oxidation is called oxidizing agent. And this is, hydrogen is the substance. Look here. It removes the oxygen from copper oxide. Therefore, it is called reducing agent. Clear? So, reducing agent. And the substance which gives oxygen, after giving the oxygen, it gets reduced. So, this is oxidizing agent is also called substance reduced. Then, reducing agent, it is also called, look at, this is the reducing agent. It takes the oxygen and it gets oxidizes to water. It is also called substance oxidized. Hope that you have understood. And this is the chemical reaction for oxidation and reduction. Look here. Here it gives oxygen, and here it takes oxygen. So oxidation and reduction both can be seen. I'll take one more example for this. It is H2S plus Cl2. It gives rise to S plus HCl. Equation is not balanced. It is 2. Here we can write 2. It's correct. Observe. This is the substance. H2S is the substance which is ready to give hydrogen for reduction. See that? And this is called, it is called reducing agent. And this is the substance which removes hydrogen from hydrogen sulfide and forms hydrogen chloride. This is called oxidizing agent. Clear? So once I will write the definition of oxidizing agent and reducing agent. And before that, let me tell you the definition. Listen carefully. See, the substance which gives oxygen for oxidation, or the substance which removes hydrogen for oxidation, is called oxidizing agent. This is called substance reduced. Next, reducing agent. The substance or the chemical substance which gives hydrogen for reduction is called reducing agent, or the substance which removes oxygen from a substance is for reduction is called reducing agent. Hope that you have understood. Now let me write the definition of both. Observe. Here I have written the definitions of both. Oxidizing agent, the substance which gives oxygen for oxidation, or the substance which removes hydrogen for oxidation, is called oxidizing agent. Here its abbreviated form can be written as OA. And observe, reducing agent, the substance which gives hydrogen for reduction, or the substance which removes oxygen for reduction, is called reducing agent and is abbreviated as RA. Reducing agent is also called substance reduced, and substance oxidized it is. Substance oxidized. And oxidizing agent is also called substance reduced. Here I have taken some of the examples for redox reaction. I will explain that later, but in this, first we shall identify only oxidizing agent and reducing agent. Oxidizing agent, could you tell? The substance, very simple, you just observe the reactant side and the substance which has oxygen, it is able to give the oxygen for oxidation. That is called oxidizing agent, which is, it is CuO, right? Then which is a reducing agent? Obviously, remaining one will be reducing agent, that is H2. Whereas, observe, in second one, oxidizing agent and reducing agent. Please keep observing them. Here hydrogen sulfide reacts with chlorine gas to form sulfur and hydrogen chloride. Consider only LHS part. See, this is, it is hydrogen is there. S2H has hydrogen. So this is the substance, chemical substance which is ready to give hydrogen for reduction. The substance which gives hydrogen for reduction is called reducing agent. So here H2S. Clear? If hydrogen is there, it's very simple. Reducing agent. And chlorine, this is the substance which removes hydrogen. What do you call the substance which removes hydrogen? It is called oxidizing agent. So Cl2. Clear? Similarly, one more example, just keep observing. It is zinc oxide reacts with carbon to form zinc and carbon monoxide. Is it not? Here are right, oxidizing agent and reducing agent. Then which is oxidizing agent? Just observe only the LHS part, that is reactant side. Zinc oxide has oxygen. Obviously, it is ready to give oxygen. So, therefore, it is called oxidizing agent. And carbon is ready to take oxygen from it. So, it is called reducing agent. Clear? And all these are examples for redox reaction, where we can see oxidation and reduction simultaneously. How this is observed? Let me go for explaining that. Copper oxide reacts with hydrogen to form copper and water. Here in copper oxide, oxygen is there. This oxygen is removed from copper oxide. So this is, and it is reduced to copper. So removal of oxygen. What it is? Removal of oxygen is nothing but reduction. Clear? Then hydrogen takes this removed oxygen and get oxidizes to water. Here addition of oxygen. Addition of oxygen. Therefore it is oxidation. Oxidation. Observe it. Both have been taken place. Reduction and oxidation. So it is an example for redox reaction. Similarly, I will go for this. Here, just keep observing. Zinc oxide get reduced to zinc. That means how it has been reduced to zinc? Because oxygen present in it is removed. What do you call this? Removal of oxygen. Removal of oxygen is reduction. Clear? And this removed oxygen is added to carbon, then carbon oxidizes to carbon monoxide. So, as it is addition of oxygen, it is called oxidation. Clear? You just come across the second one. Observe it. Here you can notice that hydrogen sulfide reacts with chlorine to form sulfur and hydrogen chloride. Here hydrogen sulfide get reduced to sulfur. How? Because hydrogen is removed. So what do you call removal of hydrogen? Removal of hydrogen is nothing but oxidation. I hope that you have understood. When the hydrogen is removed, this will be added to chlorine, then to form hydrogen chloride. So addition of hydrogen, it is nothing but reduction. Clear? Therefore, it is also an example for redox reaction. Hope that you have understood. Now, please go for copying from there to here. Then after that, I'll go for giving you some more examples. Copy. Observe these examples. Fourth one, manganese dioxide reacts with hydrogen chloride to form manganese chloride, water and chlorine. Here we have to identify oxidizing agent, then reducing agent. Similarly, here also oxidizing agent, that is sulfur dioxide, reacts with hydrogen sulfide to form water and sulfur. Here oxidizing agent and reducing agent. Very simple. Just consider only LHS part. Look at oxidizing agent. This is the compound containing oxygen. It is ready to give oxygen for oxidation. Therefore, oxidizing agent is MnO2. Look here. Then similarly, hydrogen chloride. Obviously, this is ready to remove oxygen from manganese oxide. Therefore, it is called reducing agent, HCl. In the same way, here, in this, sulfur dioxide is oxidizing agent, oxygen is there. Hydrogen sulfide, it is reducing agent. Clear? Then these two are also examples for redox reaction. Because, look here, MnO2 get reduced to MnCl2. For reducing, what has been removed? Oxygen is removed. So, removal of oxygen, it is reduction. Right? And this removed oxygen is added to hydrogen. Then hydrogen chloride oxidizes to chlorine. Right? It takes oxygen from MnO2 and becomes 2H2O, water, then chlorine gets separated. So here hydrogen is removed. So removal of hydrogen is nothing but oxidation. Here I write minus H2. Removal of hydrogen, it is oxidation. It's the same way here. Sulfur dioxide. Here oxygen is removed from sulfur dioxide. It gets reduced to sulfur. Right? So this removal of oxygen is reduction. Clear? Then this hydrogen sulfide, in this, whatever the oxygen is removed, this is added to hydrogen, and the removed oxygen is added to hydrogen to form water. Clear? So this is an example for oxidation, that is addition of oxygen. Addition of oxygen, it is oxidation. Hope that you have understood. Dear students, with respect to oxidation and reduction, we have some more information, particularly effects of oxidation. So we can go for discussing that in tomorrow's class. Okay. So before concluding today's class, again I am reminding you, whatever the experiments and chemical reactions we have learned today, please practice them today itself without fail. Don't keep anything pending. Got it? I think within 2 days only we are going to finish the chapter chemical reactions and equations. Please keep on practicing. Don't stop anywhere else. Just keep practicing each and everything what we have taught in this chapter. Okay. With this, let us stop the class. Thank you very much.